Endocrinology Minutes with Cyan. Endocrinology is a scientific and medical discipline focused on hormones, their physiological functions, and the related disease. The essential subject of endocrinology is the signaling that coordinates and controls the functions of multiple organs and processes. Hormones can be defined as chemical signals synthesized in discrete glands, secreted into the bloodstream, and act on distant tissues by activating receptors on cell membranes or in the nucleus, usually in a regulatory fashion. The essential subject of hormones includes their biosynthesis, sites of action, transport, and metabolism. Secretion of hormones. This drawing shows the main endocrine glands and the hormone they mainly secrete. However, not all hormones are formed in dedicated and specialized endocrine glands. Leptin, which regulates appetite and energy expenditure, is formed in adipocytes, thus providing a special signal reflecting the nutritional state of the organism to the central nervous system. The cholesterol derivative, 7-hydrocholesterol, the precursor of vitamin D, is produced in the skin keratinocytes by a photochemical reaction. Transport of hormones. Hormones must be able to travel in the bloodstream and diffuse in effective concentrations into tissues. Water-soluble hormones are readily transported via the circulatory system. Lipophilic hormones bind to soluble proteins that allow them to travel in the aqueous media of blood at relatively high concentrations. For example, insoluble hormones like the steroid and the thyroid hormones are bound to the carrier plasma glycoproteins such as the thyroxine-binding globulin, sex hormone-binding globulin, and corticosteroid-binding globulin as well as to albumin. Hormones in the bloodstream often are associated with binding proteins to allow their solubility, keeping them from degradation and renal secretion, and regulate their stability in the extracellular space. Hormone binding proteins primarily serve distributive and reservoir functions. For example, although the absence of vitamin D binding proteins in mice reduces the circulating concentrations of vitamin D, the mice show enhanced susceptibility to a vitamin D deficient diet, while they show less susceptibility to vitamin D intoxication. Control of the hormone secretion. Firstly, hormone secretion adheres to circadian rhythms. Secondly, there is a peripheral feedback mechanism. Networks of reciprocal interactions allow for dynamic adaptations and shifts in environmental signals to maintain homeostatic integrity. These regulatory systems embrace the hypothalamic, pituitary, and target endocrine glands, as well as the adipocytes and lymphocytes. Peripheral inflammations and stress elicit cytokine signals that interface with the neuroendocrine system, resulting in hypothalamic pituitary axis activation. Some hormones are regulated by the effects they elicit. Take the parathyroid and pancreatic secreting cells as instances. Parathyroid hormone secretion is induced when serum calcium levels fall, and the signal for sustained parathyroid hormone secretion is abrogated by rising calcium levels. Hormone measurement. Endocrine function can be assessed by measuring levels of basal circulating hormone, hormone-binding proteins, or evoked or suppressed hormone through injection of trophic hormones including thyroid-stimulating hormones, adrenocorticotropic hormone, or pharmacologic stimuli. Radioimmunoassays use highly specific antibodies that uniquely recognize the hormone or a hormone fragment to quantify hormone levels, while enzyme-linked immunosorbent assays employ enzymes instead of radioactive hormone markers. Hormone concentrations often need to be standardized for fasting, environmental stress, age, and gender. When hormone secretion is clearly episodic, timed samples are required. Early morning and late evening cortisol measurements, 24-hour sampling for growth hormone measurements are appropriate reflections for secretion peaks or nadirs. Endocrine diseases. Endocrine diseases fall into 5 categories. Firstly, hormone overproduction. In some cases, Genetic abnormalities like 11-beta hydroxylase gene cause abnormal regulation of glucocorticoid synthesis or release. More often, home overproduction are caused by an increase in the total number of home-producing cells and their increased secretion. Just take hyperthyroidism of Graves' disease as an example. Secondly, home underproduction. The causes include but not limited to surgical removal of parathyroid glands, tuberculous destruction of adrenal glands, iron deposition in beta cells of islets in hematochromatosis, abnormal development of homo-producing cells due to gene mutations, abnormal synthesis or regulation of homes. Thirdly, altered tissue responses to homes. The insulin resistance in muscle and liver, central to the cause of type 2 diabetes mellitus, is complex in origin, resulting from inherited variations in many genes as well as from theoretically reversible physiologic stresses. Fourthly, tumors of endocrine glands. Tumors of endocrine glands often result in home overproduction symptoms due to compression on adjacent structures, and they spread throughout the body. The last, excessive home inactivation or destruction. An example is the type 3 iodothyronine deiodinase, which inactivates T3 and T4 by removing an inner ring iodine atom from the iodothyronine, blocking its nuclear receptor binding, causing consumptive hypothyroidism. This kind of hyperthyroidism is caused over expression of a home inactivating enzyme in a tumor. Diagnostic and therapeutic uses of homes. Ablation of endocrine gland function due to genetic or acquired causes can be restored by home replacement therapy. In general, steroid and thyroid homes are replaced orally, whereas peptide homes require injection. Homes can also be used to treat disease associated with glandular hyperfunction. Estrogen receptor antagonists are used for some patients with breast cancer, and gonadotropin-releasing home analogs may downregulate the gonadotropin axis and benefit patients with prostate cancer. Improved home delivery system including computerized mini pumps, intranasal sprays, pulmonary inhalers, depot intramuscular injections, and oral peptide formulations will also enhance patients' compliance and improve ease of administration. Insulin delivered by inhalation has already been approved for use. Prolongation in the half-life of peptide homes make infrequent administration possible. For example, a once-weekly preparation for exenatide, a glucagon-like peptide 1 analog, has already been approved for the treatment of type 2 diabetes. Prospects. New homes are continually being discovered, from the recent focus on major regulators of metabolism and phosphate homeostasis to the continued quest to identify ligands for orphan nuclear receptors and G-protein coupled receptors. Although endocrinologists pride themselves with having logical treatments for many diseases, these treatments seldom address their underlying causes. Thanks for watching. If you enjoyed this video, just replay it. If you have any questions or suggestions, feel free to contact me through email. If there is the next episode, see you then!